Welcome back to ONELVXE Studios. Today we are going to be demoing the ONELVXE material pipeline and going over how exactly to use it, how to install it, and looking at the various parts of said pipeline. To install the ONELVXE material pipeline and the texturing add-on, start up a new Blender file. Once you've done so, press Ctrl-Alt-U to open up your user preferences, and then navigate to the Install from File button. Click this button and go locate the add-on script folder for the ONELVXE material pipeline. Find the ONELVXE textures Python file, click it, and press Install from File. Once you've done this, if you click Material underneath the categories, you will see ONELVXE textures listed underneath. Just make sure you click the checkbox and save user settings. For the purpose of this demo, I've created a simple scene. In this scene is a model composed of three parts: the brain, a shell, and a base, a studio backdrop, as well as image-based lighting. If I press Shift-Z, you can get a better look at the lighting that we're going to be working with here. Now, once you've downloaded and installed the add-on into your user settings, the first thing you're going to want to do is use the ONELVXE custom startup file. So if you use that startup file, you will press Ctrl-U to save it as a startup file. So every time you start Blender, you will automatically have the correct texture nodes and the correct shading nodes built right into your file. Now, if you're starting a new scene and you want to have your own custom startup file without the extra additions that I've made, the best thing for you to do is press Shift F1 and append in the studio shading material. It's based on the Cycles Disney shader, and it can be accessed by going to the custom startup file folder and clicking on the ONELVXE startup.blend. Once you click on this, click Material and bring in the ONELVXE Surface Standard material. In an effort to add some dramatic flair to this tutorial here, I have turned on film emulation over here in the color management panel, made some adjustments to exposure and gamma values, and then I've turned on use curves and just up the contrast slightly. On top of that, I have also added a sun lamp for a fill light and an area light for rim lighting. I'm sorry, that sun lamp is actually my key light here. Now that we've set up our scene, added some lighting, and done some color management, we're going to look at the ONELVXE Surface Shader. So if you're using the custom startup file and you're following along, change from free space under screen layout to materials. Here you will see if you have the standard surface applied to your model, you will see the ONELVXE Surface Standard shader here. Now, this is an iteration on the Cycles Disney shader that was developed and put out by us about a month ago. So, unlike the last shader, this shader doesn't have a bunch of extra sliders to control which shading model you're using. It's not nearly as confusing. It's much more concise and a lot easier for you to use. I'm going to go ahead and turn on preview rendering here so you guys can see what I'm doing. Now, the first thing that you'll want to take note of is all of these shader outputs here on the right of the node. You have dielectric shading, metallic shading, the surface metallic output, this float output that we'll get into momentarily, anisotropic metallic, glass, dispersion, subsurface scattering, metallic plus Clearcoat, anisotropic plus Clearcoat, subsurface scattering plus Clearcoat, and displacement. So all of these shading models are PBR based. If I was to pop open the shading node, you'll see inside I have done some node noodling for you and basically set up the shader to make it extremely easy for you to use and get physically based rendering right out of the box. Now, like I said, there are multiple shading models here. To switch between shading models, if you're using Node Wrangler, just press Control, Shift, and then left click, and that will switch you to a different type of shading. So right now I'm using metallic shading. I can keep iterating and go to anisotropic metallic, glass, glass dispersion, subsurface, etc. On top of that, there are also global values here. So this is the surface color, and this surface color will affect everything except for subsurface scattering, and that is it. That is the only thing that it will not affect, as well as a metallic rim color. So if I was to change this surface color here and change it over to green, you can see that the dielectric shading has now changed to a green dielectric shader. If I switch to metallic shading by pressing Ctrl-Shift-L, my metallic shader is also green. So these are global controls that allow you to quickly iterate on your materials here and mix between them and kind of use them at your will without having to go in and change a bunch of individual settings. On top of that, there is also this surface metallic input here. This is usually used in conjunction with the metallic texture. PBR texturing uses metallic and roughness mapping. Metallic maps are specifically for metals. So if you have a metallic map, as you'll see in the texture pack, most of the metallic maps are going to be completely black because most materials are not metallic. Now, when you start diving into the metals, there will be certain parts of those metals that are going to be actually metal, and then other parts that are not going to be metal. And so those parts of the texture will be black. When you input a metallic texture into this socket here, you can then blend between any of your shading models here along with this metallic output using a mix node. So an example of that would just be to add a mix shader, plug in our dielectric shading model, plug in our metallic shader, and then use this surface metallic output as the factor input. Since the surface metallic map is from 0 to 1, it's mapped from 0 being black and white being 1. The closer this fact value gets to 1, the metallic shading will be used, and the closer it gets to 0, the dielectric shading will be used. So this is very useful if you have a painted metal or an object that needs some parts metals and some parts not. There is also the surface roughness, which is also a global value. So if I change this, you can see our surface starts to get a little bit rougher. And this surface roughness also is applied across the board for every single material here, except for Clearcoat. Clearcoat has its own set of normal and roughness inputs, and that is to control if you want to add an extra layer of reflections on top of your materials, you would use this metallic plus Clearcoat output. Usually you don't want to use that with dielectric because the reflection is already calculated correctly for dielectrics. The reflection is already calculated correctly on top. Lastly, there is a surface normal input that will also take a texture map, and the surface displacement input that will take a texture map. So you can plug the surface displacement output up into the displacement node here, and it will displace your material. This now works in the cycles supported feature set in Blender 2.77. So feel free to use that and use the displacement textures that are provided with the pack. And then after we have gone over after we've looked at these global values, there are also these more specific controls. So the first one is metallic rim. If I switch to metallic shading, and that's the only instance in which metallic rim will actually work. Once I've switched to it, and let's just say I change my color to a nice red here, if I change the metallic rim color to say a blue, you'll see the rim of my now metal material becomes this bluish hue. So it realistically calculates what the rim color of your metal typically would be. There is also anisotropy amount and anisotropy rotation and anisotropy tangent, which is used for anisotropic metals. If I switch to anisotropy, let's reset our rim color back to default and change our surface color to a darker red here. First thing we'll do is bump up the roughness so we can see that anisotropic shading. And as you can see, now we're getting anisotropic highlights here. I can change the rotation of those highlights, and I can change the amount all the way up from 0 to -1, etc. Typical anisotropic controls. There's also subsurface scattering. So the subsurface scale, color, and radius scale all give you the typical subsurface control that you would have using the new subsurface scattering node. So this is the node here. It's based on the Christensen-Burley model, which is much faster and much better for cycles. The radius input has been separated via RGB. So I pop open the custom subsurface scattering node here. You'll see that there is this subsurface radius init node group here. I have separated the RGB values out into RGB and put them all into multiply nodes, and then I've given them all a scale value. So what that allows for is for you to scale your radius color effectively. You can also jump in here and do some more tweaks. So if you want to push the reds up a little bit more, you can add another node in to do some math on it, or make a color change, etc. I will just tab back out to the main shader. The last thing is Clearcoat. So if I go down to metallic Clearcoat here, to see it, since I've already turned the roughness up, I'll turn that down for now. Right now you won't see anything if your roughness is set to 0. But if I zoom in here, change the color a little bit, let's make it a nice blue, turn that up some, and give it a nice rim color, put it about in there. If I turn up the roughness with Clearcoat shading on, you will start to see this Clearcoat sheen on top of it. This is a good way to generate car paint and other glossy metallic materials as well. And this Clearcoat works for anisotropy and also for subsurface scattering. So if I go to subsurface scattering here, and let me just plug that in, and let's make it a little bit darker of a color so you can see it a little bit better. So now I have subsurface scattering, and I also have reflections on the outside of it. So very, very, very cool effect. The next part of the ONELVXE material plugin is the ONELVXE texturing.surface node. This node is used to take texture map inputs here and output them on the other side to be plugged directly into your standard shader. I'm going to go ahead and plug these up, but since I don't have anything plugged into this node currently, my material will show up black, but I'm going to go ahead and do it anyway. So I'm going to plug in albedo, which goes to color, metallic, which goes to surface metallic, roughness, which goes to roughness, AO, which is normally unused unless you want to add some extra ambient occlusion to your material, normal, which goes into surface normal, and displacement, which goes into surface displacement. Let me just switch back to dielectric shading real quick and delete this because I don't need it. Now, of course, this looks all funky because I have normal strength turned up real high and I don't have a normal input currently. Let me just go ahead and reset this for you. Okay. So what's going on here is basically you are importing textures, and typically they will be mapped using some sort of generated coordinates, object coordinates, or UV coordinates. Some mapping will be done to them to scale them, rotate them, move their location around, etc. And from there, they'll be plugged into this texturing surface node. Inside of here, there isn't really much going on. The major things are the albedo, normal map, metallic map, and roughness map are basically getting just routed straight out. So this kind of serves as an extra node just to kind of hold them. But the main thing that is happening is this camera ray optimization. Essentially, we are taking a light path node and using the camera ray output, and we are mixing between the black. We're mixing between black and the camera ray, essentially. So what happens here is any color that's input, so this is from our displacement map, any color that's input into the color 2 socket, when the camera ray hits that color or hits that surface, or in other terms, if this FAC value is at 1, then it will use the displacement map. If the FAC value is at 0, or there is no camera ray hitting the surface, then it will use black as the color output. What this does is it optimizes your scene to remove bump and displacement mapping from Cycle's camera ray calculation. This has resulted, from my experience, in around a 15 to 20% decrease in render times. So my scenes typically render 15 to 20% faster using this method. There's typically no disadvantages to using this. I haven't seen any differences in rendering various materials and various things by taking the bump mapping out of my camera ray calculations. So yeah, this is a great speed up. You'll see anywhere from about 5% decrease in render times if you're using, or if you're working on a much larger scene, up to around 30%. I've seen some crazy improvements using that method. Now, the only other thing on this node that you need to be aware of is the normal strength and the normal distance. These just control how strong your normal values are, and then it controls how high they come off of the surface. If you're using displacement mapping, over here on the other side of the node, you'll want to add in a converter math node, plug in surface displacement into the top output, switch to multiply, and then plug that into the displacement output of your material. You can then use this multiply node here to control how displaced your material ends up being. So if I set it to 1, it'll use the default map, and if I set it to 0.5, it'll basically multiply the effect of my displacement map to 0.5 and decrease the overall displacement on my material. Now that we've covered the most important nodes from the pack, the surface standard node and the texturing.surface node, we're going to dive into how to actually use the provided materials and textures with these two node groups. The first thing you're going to want to do is open up your properties window in the node editor by pressing N. There is a ONELVXE Textures drop-down arrow here that you can use to expand the options for the add-on. This add-on imports textures by selecting a whole allowing you to select a whole texture folder and import textures that way. So in this case, we're going to go grab a wood texture. So I'm going to hit select folder here, and I already have my wood folder unpacked. And when you download the group, or when you download the texture packs, you will see, once you've unzipped everything, you'll see these material previews inside of the individual folders. So these will give you a better idea of what the materials inside will actually look like. I really like this varnished walnut wood material, so I'm going to click that folder. Inside there are 1K, 2K, and 4K resolution versions of the texture maps. In this case, I'm going to use 4K, but you are free to use whatever version that you like depending on your needs. Once you select the texture folder, click it, and all your textures will start appearing. Just hit select texture folder. You don't have to actually select any of these textures here. Once you've selected your folder, you'll see that the available texture group in that folder is varnished walnut. So this add-on works by looking at the prefix name. So usually that's the description of the actual texture you're going to be using, in this case varnished walnut, and then it looks at the suffix name. So when you start naming your textures, there are specific naming conventions that you'll want to look at to make sure that the add-on can recognize them. Those suffixes will be included in the documentation that I will provide a link to at the end of this demo. So please refer to that when authoring your own textures and deciding to use them with this pack. Now that we have our varnished walnut group selected, we are going to hit import textures. This will generate a new node group with your imported textures inside. I'm going to drag it to the left of the ONELVXE texturing surface, plug up the vector from my mapping node into the vector input here, make it a fake user so it sticks around, and let me turn off preview rendering just so this will speed up. I've done this a few times, so to make it look like I want it to look, since I haven't done any UV mapping for this material here, I'm just going to use object mapping, and I'm going to set the rotation to 90 so that it faces the camera, and scale it up to say 7 for each vector, and switch to texturing so it actually scales up and not down. Let's pop this bad boy open and see what's inside. So as you'll see, it has created 6 image nodes for all of the maps included inside of that varnish walnut folder. It's created a albedo, normal, metallic, roughness, displacement, and AO map. From there, it has also set the correct image nodes to color data or non-color data. So in this case, albedo, which is a color texture, has been set to color, but everything else, with the exception of AO, has been set to non-color data, which is usually the correct way to interpolate these textures. Also inside is this vector socket here that is just plugged up into all of the nodes to make sure that they are mapped correctly. From here, once you've loaded them, just plug the outputs from your bridge texture node into the surface texturing node. So albedo to albedo, normal to normal, metallic, roughness, displacement, and AO. I'm at first going to turn the normal strength off, turn that down to 0, and turn displacement down to 0, so we can see the effect as I build this up. Since wood is a dielectric material, I'm also using dielectric shading here. So let's turn back on preview rendering and start plugging things up so we can see what we get. It's blue for now, but let's plug in albedo. And now we can see our wood start to come in. This is just the albedo texture. Metallic, it's not being used here, but we're going to plug it in anyway. And then let's plug in roughness, which is going to give it correct roughness mapping. Let's plug in normal. And let's plug in displacement. So now, as you can see, I'm starting to get a nice looking wood material. To make it look just a tad bit better, I'm going to go back into color management and bump up the exposure so you can see it a little bit better. And change the gamma back to 1. So that's looking a little bit more like it did in the material preview. So looking good there. Now let's go back and change the mapping because it's slightly too big. So let's change it to 4, make it a little bit smaller. And then let's go ahead and start adjusting our normal strength. So as I start to bump this up, you can see the normals of the surface start to come in a little bit. Looking very, very nice. So I like it at about 0.45, I think. That looks pretty nice. So I'm going to unplug surface normal for a second and hop on over to displacement and mess with that. So let's turn displacement up to 1, and you'll see it gets all gross. If you want it to be extra displaced like this, then go right ahead. I think it's a little bit too strong, so I'm going to turn it down to 0.375. Much nicer. And then let's plug back in our normal output. And there you have it. That is your wood texture, imported straight from the texture library, right into its own group node, plugged correspondingly into the texture surface, and then from the texture surface node into the surface standard node. So very simple, very easy way to import and manage your textures without much effort. Now, let's say that you want to change the resolution of the maps you're using. So a good example of this is in the material library. All of these materials have already been set up for you. However, they were set up using 4K texturing. So if you were to import one of those material groups and apply it to one of your objects, none of the maps have been packed into the blend file because we're dealing with 100 textures here, and as such the blend file would be around 10 gigabits, so too large for that to work. So to get around that, what you can do is load new maps. So what we're going to do here is go back and select a new texture folder. Right now we're in the 4K folder, but we're going to scroll up and select 1K instead because we want to switch our texture resolution. So select that texture folder. It'll show the same output here. And then just make sure that the texturing, the ONELVXE texture node is selected, the one that you have generated by pressing import textures. And from there, hit load new maps. And it now will have loaded the 1K version of all of your maps. You can't see this here, it doesn't really show up. But if I pop open let's open up a diffuse PNG 1, press in, you will see that the second generated diffuse texture that we loaded is 1024 by 1024. If I flip back to the first one, which is the one we were using initially, that's in 4K, you'll see that it is 4096 by 4096. So if you are importing textures from the pack, or you are using the material library and you want to quickly change your texture resolution, just select the texture folder with the resolution that you want to change to. And then from there, as soon as this gets back, hit load new maps, and it will load the new maps right into your texturing node without you having to do anything. As I hope you can see from this demo, the ONELVXE material pipeline is an artist-friendly tool that allows you to quickly and easily author textures and create amazing PBR materials for your blend scenes. Included in this pipeline are 100 ready-to-go PBR materials, as well as the surface standard node, the ONELVXE texturing surface node for optimizing your textures, and the ONELVXE texture bridge, which adds textures straight into your scene. So you can use this add-on with other texture repositories such as Polygon and cgtextures.com. Thank you and have a blessed day.